Hello and welcome to the ClassFly community. I'm Vedika. In this video, I'll be covering the topics threaded binary trees, its types, and binary search tree. I hope you have seen the part 1 and part 2 of trees module. So this is the continuation, part 3. Starting with the first topic, threaded binary trees. Definition: in a binary tree, more than 50% of linked fields have null values and more space is wasted by the presence of these null values. These linked fields contains null characters which can be replaced by address of some nodes in the tree which facilitate upward movement in the tree. These extra links which contain addresses of some nodes or pointers are called as threads, and the tree is termed as threaded binary tree. In general, a threaded binary tree is a binary tree which contains threads, that is, addresses of some nodes which facilitate upward movement in a tree. Now let us see what are the various types of threaded binary trees. So there are of three types: in-threaded binary trees, post-threaded binary trees, and pre-threaded binary trees. What is an in-threaded binary tree? Definition: in a binary tree, if L link, that is left link of any node, contains null, and if it is replaced by address of the in-order predecessor, then the resulting tree is called left in-threaded binary tree. And if the R link, that is right link of a node, is null, and if it is replaced by in-order successor, then the resulting tree is called right in-threaded binary tree. So this is a binary tree with a headed node. Now in this tree, if the right link of the node is null and if it is replaced by the address of the in-order successor using the dotted lines, then it is known as a right in-threaded binary tree, as you can see in the diagram. Now let us see how to implement this right in-threaded binary tree in C language. So to implement a right in-threaded, an extra field R thread is used. So if this R thread is 1 corresponding to right link, it represents a thread. And if R thread is 0, the right link represents an ordinary link connecting the right subtree. So struct node int info struct node star L link. Star L link is the pointer to the left subtree. Struct node star R link is a pointer to the right subtree. Int R thread. This int R thread, if it is 1, it indicates the presence of a thread, otherwise 0 indicates the absence of a thread. Type def struct star node. Now this is a left in-threaded binary tree. So the left field of a node is null and it is replaced by the in-order predecessor as shown, then the tree is said to be left in-threaded binary tree. So here also an extra field L thread is used, where 1 indicates presence of a thread and 0 indicates ordinary link connecting the left subtree. So this node can be defined as struct node int info struct node star L link, where star L link is a pointer to the left subtree, struct node star R link, pointer to the right subtree, int L thread. Here also same, 1 indicates a thread or else 0 indicates an ordinary link. Now this is an in-threaded binary tree. So here in-threaded binary tree is the one which is also left in-threaded and right in-threaded. So its structure is int info struct node star L link struct node star R link, pointer to the left subtree, pointer to the right subtree, and L thread and R thread means 1 which indicate a thread or else 0 it indicates an ordinary link. So a tree can also be empty. So when the tree is empty, the header node is represented like this. The tree is attached always to the left field of the header node. So now let's see what is pre-threaded binary tree and post-threaded binary tree. So pre-threaded binary tree definition: if a binary tree, if L link of a node contains null and it is replaced by address of the pre-order predecessor, then the resulting tree is called left pre-threaded binary tree. And if in a binary tree the R link, that is the right link of any node, is null, then it is replaced by address of the pre-order successor, then the resulting tree is called right pre-threaded binary tree. And these pre-threaded binary trees are both left and right pre-threaded. Post-threaded binary trees: so in a binary tree, if L link, that is left link, contains 0 and it is replaced by the address of the post order predecessor, then the resulting tree is called left post threaded binary tree. Same goes with the right link. So these post-threaded binary trees are the one which is both left and right post-threaded. So advantages and disadvantages. Advantages: first one, in a binary tree, more than 50% of linked fields have null values and more memory space is wasted by storing these null values. So this wastage of memory space is avoided by storing addresses of some nodes. Second one, traversing of a threaded binary tree is very fast. This is because it does not use implicit or explicit stack. Third one, computations of predecessor and successor of given nodes is very easy and efficient. Fourth, any node can be accessed from any other node. That means using threads upward movement is possible and using links downward movement is possible. Thus, in a threaded binary tree, we can move in either directions. This is not possible in an unthreaded binary tree. Fifth, even though insertion into a threaded binary tree and deletion from a threaded binary tree are time-consuming operations, they are very easy to implement. Disadvantages: here extra fields are required to check whether a link in a thread or not and hence occupy more memory when compared with unthreaded binary trees. Second, insertion and deletion of a node consumes more time than its counterpart because many fields have to be modified. Now let's go to our next topic, binary search tree or BST. So it is a binary search tree is a binary tree in which for each node, say x in the tree, elements in the left subtree are less than info of x, that is the root element, and elements in the right subtree are greater than info of x. Every node in the tree should satisfy this condition. So if the left subtree or right subtree exists, but they can also be empty. So a binary search tree can be empty. So this is an example of a binary search tree. In this example, 100 is the root node, 50 and 200 are its subtrees, left subtree and right subtree. Here we can see that the elements in the left are smaller compared to the elements in the right. Also, 50 is the root subtree for 25 and 90. So here the left subtree, that is 25, is smaller than 90. So this is binary search tree, and these two are some other examples of binary search tree. So the operations performed on a binary search tree, the expressions trees and tree operations using sequential representation will be covered in the next part. Thank you.